Math is the thing that computers are best at. With the logical reasoning and easy steps to follow, computers were designed specifically to do math faster and more accurately than humans can. This has opened up a world of possibilities to us, and today we will look specifically at the power of expressions in computer programming. My name is Miss LaRose, and this is your lesson on expressions. Welcome, kiddos. First, I want you to try and imagine playing your favorite video game, but you have to recalculate your health each time you get hit, or you have to do the math yourself to know how much damage you did to your opponent. Welcome to tabletop role-playing games.
Dungeons, dungeons, and more dungeons!
Despite the fact that tabletop RPGs and online RPGs work almost identically, tabletop systems like D&D, GURPS, and World of Darkness tend to be seen as more nerdy than their digital counterparts. This is partially because of the cool graphics you get when you play a video game, and partially because the computer does most of the heavy lifting for you in game functionality. Video games have algorithms in place to keep track of your health, how much damage you deal, what skills you have, and where you are on the map. And, you guessed it, all these features are made possible by math. Starting out, you need to know what an algorithm is. An algorithm is just a set of instructions to complete a task. To help create our algorithm, we need to understand the order that the computer reads the code, or the sequencing of a program. Your code will be read from top to bottom by the computer. As an example, if I wanted to print out a variable named time, so I wrote my print statement at the top of the page, then created my variable called time and set it to be noon. When I run this code, it will output an error because we tried to print the variable time before we told the code what it was. So I have to switch these lines of code in order for my program to run. What this means is that our algorithms need to give the correct steps in the correct order for our program to work as we want it to. Later in this class, we will learn some methods to make your code skip around and read things in a different order. But for now, you always need to have your algorithm written in a way so that you can read it from top to bottom. There's so much more about algorithms in programming that you will learn as we go on, but this is all we need to worry about in this particular lesson. Now, we need to look at two different data types that are used in programming. The first one is integers. Integers in programming are whole numbers, and we just write them as they are. Whole numbers tend to be used for things like health and damage in a video game. With the ability to use integers, we are ready to look at some expressions. First, I'm going to change the variable time to be num, and I'm going to make a second variable called num2. Again, notice that I start with an entirely lowercase word, no spaces, and I capitalize the first letter of my second word. Another thing I want to take a second and point out is that variables can only be named with words. You should not use numbers or symbols in the names of your variables. Expressions are written using arithmetic operators, such as plus for addition, minus for subtraction, the star for multiplication, and the slash for division. Those are just the basics though. We also have double slash for integer division, meaning it rounds the number when it divides. Double star allows us to do exponents. Lastly, there is the modulo, also called mod, represented by the percent symbol. Modulo allows us to get just the remainder of a division problem. So as I run my code with all my print statements, you can see that the computer has done all of the math for me. We have one major difference in our code though. Our output from the division has a decimal point. This means that this is no longer an integer because it is not a whole number. This has now become a float. A float is shorthand for floating point numbers, and it just means that it includes a decimal. We write them out just like we would our integers. Floats are used when you are in need of more specific data, are often used in the background of your game to determine your location on the screen, the tilt or angle of your camera, or the amount of time you have been in the game. This is important to remember that your program will automatically convert integers to floats if the equation requires it, but it will not convert a float back to an integer if the decimal is no longer required. We'd have to use a data type conversion by writing the type of data we want in front of the equation and then putting parentheses around the equation. Knowing how to convert data types like this is very important because some things can only be done with specific data types, such as using arithmetic operators, which can only be done with integers or floats. Something else to note is that a computer will follow the order of operations calculations when completing an equation. If I have a base damage of 20 plus 10 damage bonus against a particular type of monster, and I just added a modifier that multiplies my base damage by 3, the computer will be able to just run the number and know that I'm doing 70 damage. Pretty cool. But we can make this even better by using variables. The basic level of using variables for this is to set my numbers as variables and then replace each time I have written the numbers with the variable names. This allows us to use the same number over and over again without having to remember what those numbers are. And thus, with the magic of video editing, you now have access to some of my character stats in one of the games I play. Now, I can have the computer determine how much damage I normally do, compared to when I have my modifier active, compared to when my brother gives us a group bonus. And I can check and see how much damage I will take from certain types of enemies. The next step up from this is I can reset my variables based on the results of these different math problems. So instead of printing the results, I can reset my variables to be the new values. This makes it so that my user doesn't have to see a bunch of results they don't need, and now we can just output our final results. This is another great way to do multiple step equations. The last thing we can do is simplify updating our variables further by using assignment operators. In our last video, you learned that an assignment operator is the equal sign, and that it is used to create variables by setting a variable name equal to a value. But if we add an arithmetic operator to our assignment operator, then it will do the math and reset the variable at the same time. To do this, start by writing out the arithmetic operator I want to use, then write out the assignment operator, finally the second number I want to use. When I run this now, my health variable changes each time I reset the variable based on what it was before, and the arithmetic operator that has been assigned to it. As you can see, we're now setting up algorithms that can track my user health or specific monster health in a game. This makes things much faster and smoother than trying to do it all by hand. Trust me, I've messed up my math plenty of times, and this has been sad, because I could have done more damage when attacking. Obviously, there's a lot more code that goes into building a video game, and this is just me writing out examples of 1 or 2 lines that would exist in all that network of code, leaving off the lines of code that would tell the computer when to do these actions. But that's programming for another lesson. Thank you for watching. I hope you feel like you have a better understanding of expressions as well as integers and floats, and I hope to see you all in class. Bye.